So in this video, I want to look at the surface area to volume ratio. So let's imagine that we're told that our alveoli, we know these spherical air pockets, are going to increase the surface area to volume ratio in the lungs of a mammal. Now, if an alveolus has a diameter, let's say, of 0.25 millimeters and a surface area of 0.196 millimeters squared, they want us to calculate the surface area to volume ratio of this alveolus, and they've told us that we need to use this formula, which is the volume of the sphere is 4/3 pi r cubed. So the first thing we need to do then is we need to calculate what our radius actually is. So we do our 0.25 divided by 2, and that gives us our radius of 0.125. Now we need to put that into the equation. So we know it's 4/3 times pi times 0.125 cubed, which will give us the answer of 0.00818123086. Now, I'm not doing any rounding at this point, and that's important because they've asked us to calculate our surface area to volume ratio. So I know that I should always divide my volume by itself to give me the volume to 1. So therefore, if I divide the volume by the volume, I also need to divide the surface area by the volume as well. So therefore, I need to take that number of 0.196, divide it by my calculated volume of the sphere, and that will therefore give me the answer of 23.957. I'm going to round that, and therefore my surface area to volume ratio is 24:1. Therefore, we have increased the surface area to volume ratio by having lots of these alveoli in our lungs.